friends, let's learn about acids, bases and salts, which is the second chapter in class 10 science. So what do we already know about acids and bases? We already know that acids are sour in taste and turn blue litmus red, and bases are bitter in taste and turn red litmus blue. So what is litmus? Litmus is an indicator, and according to its name, it indicates whether a given substance is an acid or a base. That means it tells us through change in color, change in odor, that is smell, or change in any other property, whether a given substance is acidic or basic. So what are the kinds of these indicators? There are natural indicators which are available naturally, for example litmus and turmeric, or there are synthetic indicators or man-made indicators, for example phenolphthalein. There are also olfactory indicators, which means they change their odor or smell when they're added to a given substance to tell us whether that given substance is acidic or basic. The examples of such indicators are onions, cloves, or vanilla. Now let us look at the chemical properties of acids and bases. How do they react with each other? How do they react with metals and non-metals, etc. So what happens when acids and bases react with metals? We find out that when acids react with metals, they release hydrogen gas along with the formation of salt. For example, calcium, which is a metal, reacts with nitric acid, which is an acid, to give calcium nitrate, which is a salt, along with hydrogen gas. So friends, here what we need to focus is on what is happening in this reaction, and we don't have to worry much about the formulae, because understand that as we go through these chapters and the first chapter of class 10 science, we'll get through these formulae as we know about the metals and non-metals. So what happens when bases react with metals? The same thing happens. A salt is formed with the release of hydrogen gas. So when sodium hydroxide reacts with zinc, which is a metal, sodium hydroxide is the base, we get sodium zincate, which is a salt, along with the release of hydrogen gas. Now let us look at what happens when metal carbonates or metal bicarbonates react with acids. So what happens is that we get a salt along with water and carbon dioxide. For example, sodium carbonate along with an acid, which is hydrochloric acid, reacts and forms sodium chloride, which is a salt, along with water and carbon dioxide. Similarly, sodium bicarbonate, which is sodium hydrogen carbonate, reacts with hydrochloric acid to give a salt, sodium chloride, along with water and carbon dioxide. So how do we know that carbon dioxide gas is released? Because it's colorless. What we do is we pass this gas through lime water, which is calcium hydroxide. We get a white precipitate, which is calcium carbonate, only when carbon dioxide gas is present. So the reaction goes as follows. Calcium hydroxide, which is lime water, reacts with carbon dioxide gas to give calcium carbonate, which is a white precipitate in solid form, along with water. However, when excess carbon dioxide gas is passed, this calcium carbonate reacts with this carbon dioxide gas and also reacts with water to give calcium hydrogen carbonate, which is soluble in water. So limestone, chalk and marble are different forms of calcium carbonate, that is the white precipitate that we saw in our previous reaction. So what happens when acids and bases react with each other? Not difficult to guess. Let's look at a particular activity that illustrates what happens. So when we take about 2 ml, 2 milliliters of dilute sodium hydroxide, which is a basic solution, in a test tube and add phenolphthalein, we know immediately that the color of the solution is pink. Then what do? We add hydrochloric acid dropwise to this particular solution, and the color of solution changes and it becomes colorless. This indicates that the effect of sodium hydroxide, which is a base, is neutralized by the effect of hydrochloric acid, which means acid and bases neutralize each other, and thus this reaction is called the neutralization reaction. In a neutralization reaction, acids and bases react with each other to give salt and water. So sodium hydroxide, which is a base, reacts with hydrochloric acid to give sodium chloride, which is a salt, and water. What happens when metal oxides react with acids? Not difficult to guess. The reason this is coming after the neutralization reaction is because we get the same products, which is a salt along with water. Now, the reason this is similar to the neutralization reaction is because metal oxides are basic in nature. So what happens when non-metallic oxide react with base? Again, we get salt and water, which gives us the inference that non-metallic oxide are acidic in nature. So how do we generalize the properties of acids and bases? So the reason acids and bases have similar properties, that is all acids have similar properties and all bases have similar properties, is because they have something in common. All acids, as we come to know through particular experiments, have the hydrogen ion in common. That is, they release hydrogen ion, which is responsible for their acidic activities. All bases have the hydroxide ion in common, which is responsible for their basic activities. So what happens when an acid or base is present in a water solution? So the acid, when it is present in the water solution, reacts with the water to give hydronium ion. What happens is that it releases the hydrogen ion, which is not stable by itself, and thus that hydrogen ion reacts with water to give the hydronium ion along with the metal or with the non-metal ion in the cases of acid, and the metal ion in the cases of base along with hydroxide ions. So this hydronium ion is responsible for the acidic properties of the acid. When a base such as sodium hydroxide is present in water, it releases sodium ions and hydroxide ions. The hydroxide ions is responsible for the basic activities of sodium hydroxide. So only in water, when these reactions take place, can hydronium ions and hydroxide ions form, which give these substances their properties, their acidic and basic properties. So let us come back to this neutralization reaction and observe what happens when an acid, which is generally a non-metallic atom along with hydrogen atom, combines with a base, which is generally a metallic atom along with hydroxide ion. They form a salt, which is the metal and the non-metallic part of the base and acid respectively combine with each other, and the hydrogen and the hydroxide ion, which is left from the acid and the base respectively, combine together to form water. This is why in the neutralization, when an acid and base combine together, we get salt and water. So what happens when water is added to an acid or a base? So what do we know about dilution? Dilution, my friends, is the same process when water is added to an acid or base or to any other solution, right? So what is dilution? Dilution is when the concentration of any particular solution reduces, right? So in this case, in the case of acids, the concentration of hydronium ion reduces per unit volume of the solution, and that is dilution of acids. And in bases, the concentration of hydroxide ions per unit volume of the solution decreases, and this reaction is called dilution reaction. To learn more about this chapter, to learn about pH in everyday lives, and to learn about salts, continue watching the rest of the videos. But before that, answer the question: how do we know how strong acids and bases are? Comment your answers below and let us know what you think is the right answer. To keep up with this chapter and to learn more about the important and interesting questions of this chapter, keep up with our videos and don't forget to like and subscribe to our channel. Thank you.